Hello everyone, welcome to my first video on my YouTube channel. Um, I'd like to start from the introduction of myself. My name is Nal Kardanov. I'm a developer and to be honest, I'm not professional in video production, in blogging, in streaming or some kind of that, but I had a dream for a longer period of time to make a channel about technologies, about some technology things. Um, at my daily job, I'm developer advocate at Waves platform. It's a blockchain platform. So every day I work a lot with blockchains. I write a lot of code. I talk a lot about technologies. So maybe we can also find a lot of interest in on this channel. I can talk about technologies, and maybe you will be interested in that videos. So if you like this video, just like, subscribe, share, and we'll make more videos about technologies, about blockchains, mostly about Waves, of course, because I know about Waves a lot, but I think not only about Waves. So this is first video, and in this first video, I'd like to talk about Waves blockchain, Waves approach to smart contracts. Usually, I talk about Waves, and I got a lot of questions about Waves approaches about smart contracts, smart accounts, smart assets. What is it? So in this video we'll talk about it. We'll talk about Waves blockchain itself. So again, if you like this video, like, share, subscribe. So let's start. Let's start from the beginning. Let's talk about Waves blockchain. Um, Waves blockchain is really well known because of its speed and scalability. Right now, Waves can handle more than 100 transactions per second. There was a stress test, as far as I remember, with more than 800 transactions per second. Yeah, it's really fast. And why it's fast? Because there's a technology called Waves NG. In 2015, there was a paper called Bitcoin NG, Bitcoin Next Generation. That paper describes how we can improve the speed of Bitcoin. Bitcoin isn't implemented, but Waves implemented, and now it's a Waves NG, and this technology allows to handle many transactions per second. So if you are interested more in this technology, you can go to documentation, to Waves documentation, and you can find there some description of that, or you can find original paper. I think I will add to the description of this video the link to the paper. Okay, so Waves is well known as fast blockchain, it's really cost effective also because there are low fees, really low fees. There's integrated DEX. You can issue a token on Waves and you can instantly trade with them on DEX, on decentralized exchange. Also, there are smart contracts, uh, which enables you to build decentralized applications. But Waves' approach to smart contracts is a little bit different. It not like in Ethereum or in Tron or in other blockchains. So today I'd like to talk about Waves' approach to smart contracts. To be honest, there are two types of smart contracts called smart accounts and smart assets, and we'll talk both of them, and I will show you how to write, what's the difference between Ethereum, for example. So we will talk, I think, mostly about it, but first of all, let's start from the Waves blockchain model. Waves is a proof of stake blockchain. Some technical details, cryptographic details, you can find in documentation, docs.wavesplatform.com. But today we'll talk not about cryptographic details. We'll talk about the whole approach, the whole blockchain itself, about blockchain itself. Yeah. So let's start from the beginning. Bitcoin. It was the first blockchain, the very first blockchain, and how it works. There are transactions in Bitcoin, and each transaction has inputs and outputs. So if you want to make a transaction to send some bitcoins from your account to another person's account, there are no accounts at all in Bitcoin. Let's make it clear. There are no accounts at all. You just have some key pair, private key and public key, and you just can sign transactions with your private key. So public key just like it's a recipient for a transaction. And if you want to send some bitcoins, you sign a transaction with your private key. You do not show your private key to anybody, you just sign a transaction. Okay, so each transaction has its inputs and outputs. For example, here I'd like to make a transaction. I want to send zero point 0.5 bitcoins to another account, to another public key. To do that transaction, I have to include in my transaction also input when I got that bitcoins. So in this case, I got 50 bitcoins somewhere in the past, yeah, and in my transaction, I say that okay, this is my input, and I want to make this output. In this case, I sent zero point 0.5 bitcoins to another person, and I sent back 49.5 bitcoins to my public key. Okay, so each transaction has inputs, outputs, and this is the model of Bitcoin. In case of Waves or Ethereum, there are no inputs and outputs. There are accounts. It's account-based model. For example, if you have a key pair, private key and public key, this is your account. And your account holds all of your tokens, all of your assets. Another difference between, for example, Ethereum or Bitcoin comparing with Waves is that in Waves there are a lot of different types of transactions. Let's have a look. For example, you can issue a token with only one transaction. You just have to send transaction called issue transaction with ID equals to 3, or you can reissue some tokens just like a transaction with ID 5. You can set asset script, you can make it smart. So there are different types of transactions. That's the main idea we have to understand right now. To work with tokens, to transfer tokens, to lease. The consensus mechanism for Waves blockchain called leased proof of stake, not just proof of stake, to be honest. So again, if you're interested in what is leased proof of stake, you can go to official documentation and find more details there. Right now, I'm trying just to say that there are different types of transactions. We'll get back to transactions later. It's very important to understand that to do something, for example, to store some data, you have to send a special type of transactions. If you want to, for example, just transfer some tokens, you have to send another type of transaction. Okay, let's go forward. So, for example, transaction type 4, it's a transfer transaction. It You can find like recipient here in this JSON schema, sender public key, etc. As a developer, you will see, if you work with Waves API, you will see only JSON schemas. So in this case, it's a transfer transaction. It allows to send some token from one account to another account. In this case, from sender 3PMSZ blah 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 to another account, the recipient 3NA blah 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 blah. This is how transactions look like. This is just like one example how transfer transaction looks like. In other transactions, looks different. They're different all because data data in the different transactions just like not equal. Not, for example, if you want just to store some data, you should not uh, there is no recipient for data, right? You just want to store some data in blockchain. You just want to add some data to your account. So again, if you work with transactions, you see only the JSON. Also, there are data transactions. It's really important to understand what is a data transaction. In Waves blockchain, you can store some data, and for each account, there is a key value storage. So each account it's a key private and public keys, and address, which we can get from public key always, and that address can hold some data. So we can store some data associated with that address. Okay, so we can store right now, we can store in data transactions four types of values: strings, byte arrays, integers, and booleans. About details about limitations, about fees, etc., you can find in documentation also. Maybe we'll make another video in the future about data transactions, but right now the main thing we have to understand that we can store some data in key value storage of an account. That's the main thing. That's the main idea. So, how it looks like. For example, we make a data transaction with some sender, and we make another data transaction for this sender, and we send there two key value pairs. First key is Euro USD. It's a key, and value equals to 122. Second key is market open, and value is true. So we can send that transaction, so two key value pairs. We can make another transaction, data transaction, with same key, like Euro USD, and in the end we can make a call of REST API, and we will get the latest data. So we just overwrite the first value of Euro USD with new numbers, 116, and if you will go to blockchain and call the REST API endpoint, you'll get these values. Okay, I hope it is clear. Data transactions allow to store some data, and you can get that data using REST API or in smart contracts. We'll talk about it later. So, what is a smart contract? The simplest definition of smart contract is just like a piece of code which runs on nodes, on usually on all nodes in blockchain network. Okay, but there are a lot of issues with smart contracts. For example, security risks. Uh, in the last year, errors in writing smart contracts led to vulnerabilities, and hackers exploited, and more than $400 million has been stolen by hackers. Like the biggest fail, as far as I remember, it's the DAO in Ethereum network. So I just want to say that writing smart contracts is not so easy as you can think. It's just like not like writing usual code, because usually when you write a code you can update it at any time, you control it, let's call it so. In case of smart contracts, usually they're immutable. You even can't update them if there is an error, there is a bug, sometimes you even can't update it. Another problem, another issue, there's scalability. There is a scalability issue. For example, in the Ethereum network in the end of 2017 was a game called CryptoKitties. It still works as far as I remember. But at the end of 2016 it was very, very popular, and there were a lot of users, and the Ethereum blockchain just stuck because it can't handle so many transactions. So it's very hard to to create scalable smart contracts smart contract engine, let's call it so. And last but not the least thing, when you write a smart contract, for example in Ethereum again, you have to count the gas price. Usually in Ethereum network, if you want to run a smart contract, you pay some gas, and counting the needed amount of gas is not so easy. So there are really a lot of issues, and writing smart contracts in 2019 it's still complex and still not so easy as we expect. So in Waves we tried to understand the main use cases of smart contracts, and we found three types of use cases. The first category is simple and well-defined use cases like multi-signatures, escrows, atomic swaps, etc. The second category, the second type of use cases, like really complex use cases, complicated, like CryptoKitties, Bancor. There are a lot of code, and it's not so easy to write, to debug, to test it. And last use case of smart contracts, for example, in the Ethereum network, it's just call them tokens. Yeah, the category called tokens. In Ethereum network, to issue a token, you have to write a smart contract. There are standards for smart contracts like ERC20, the most common standard for smart contracts, I think, ERC 721. There are a lot of different standards. And you have to understand that in Ethereum network there are no tokens at all. It's just like a smart contract which holds some state of this smart contract, and this is like a token. In Waves blockchain, uh, tokens are first-class citizens. You should not write a smart contract to issue a token. You just have to send one type of transaction. So all tokens are almost like Waves token in Waves blockchain. So in Ethereum, there is only one first-class citizen. It's Ethereum token, Ethereum cryptocurrency. In Waves, each issued token, it's not a smart contract. It's lightweight. It's right in the core of blockchain, and also you can even pay fees using different assets, different tokens. Maybe we will talk about sponsored transactions also in the future, but right now the main idea you have to understand is that tokens are not use cases for smart contracts in Waves blockchain, at least because um, there are lightweight tokens right in the core. You should not write a smart contract to issue a token. It's a very important note. Okay, and we just realized that there are two main use cases, two main categories of use cases: simple and well-defined, and complex. So let's go to Wave's smart accounts. What is a smart account? Um, let's start from the beginning again. Let's talk about account-based model. Right now, in Waves, as I already said, there are no inputs or outputs. There are accounts, like in NXT, like in Ethereum also, and it means that some public key owns tokens. And to spend funds, to spend that tokens, the sender provides a valid signature, matching transaction body and public key. So to make a transaction, just have to sign a transaction. So it also, the blockchain itself just checks some another properties, like it checks that your balance is not your balance allows you to make that transaction, for example. So the Waves model, it's also publicly owns tokens, and right now, to spend some funds, sender provides proofs for a script based on transaction fields, height, and blockchain data. So smart accounts allow you to change the behavior of an account. And let's make it clear, a little bit more clear. What is a smart account? It's account with some script, with a contract attached to that account. What is a script? It's just like account lock. What is a script again? It's custom predicate that either allows or denies outgoing transactions. Outgoing, not incoming, only outgoing transactions. How to make your account smart? Usually you have just simple account and you want to change the behavior of your account. You want to make it smart. You want to check not only the signature of transaction, you want to check something else. To do so, we have a special type of transactions called set script. So you have to send set script transaction with the compiled body of your smart contract. As you can see, the ID of set script transaction is 13. Yeah, and you have usual account, you send some tokens, you get some tokens, and if you want to change the behavior, if you want to change how it checks the validity of transactions, you just send set script transaction to the network. That's it. Set script transaction should contain the script, the compiled script. I think it's clear enough. So, what is a set script transaction? Script is an account lock, as I already said. It's either allows or deny outgoing transactions from the account. Um, and default lock requires signature. Custom lock, it's a predicate based on transaction type and fields, height, balance, token balance, wave balance, or any data on blockchain using data transactions. So the best intuition about Wave Smart accounts is the account, any account, is like lock. It has lock, let's say so. It has default lock, which checks the signature. Smart accounts, it's the smart account is an account with changed behavior, with changed lock. For example, that lock can be just opened, so any person, any user just can make a transaction from that account. If you say in your code, or in your smart account, if you write just like true, anybody can make a transaction from that account. So how to write a smart contract? That's the next question. Write is a programming language that was created by Wave's team and designed for smart contracts. And the main purpose why we invented a new language, the main idea is to help developers to avoid bugs, to avoid errors in their programs. It was inspired by Scala and F Sharp. It's strong, statically typed, and expression based. It's immutable and with lazy evaluation. There is a very interesting and important feature called pattern matching. If you have an experience with the Scala, for example, you'll love it. And there are no guess, there are no loops, there are no iterations. So if you write a smart contract, you have to understand that you can't iterate over some collection, for example. And we made it to keep write simple, to make to keep smart contracts simple, and to make them bug-free. So smart contracts approach. Why we invented smart accounts? Um, because it's simple, because of simplicity. Smart contracts designed with focus or user friendliness and ease of creation. It's totally true because we try to make the language as easy as it's possible. Really, write is very simple language. And because it's lightweight. As I already said, smart contracts in Ethereum faced with a lot of issues like CryptoKitties with scalability and the lightweight architecture without gas, without loops. It allows to reduce a lot of blockchain and keep it fast. And execution costs are known upfront, so you should not calculate the gas and you should not think about gas at all. You just have flat fees. Yes, there's an additional fee for smart account, but it's flat. What about limitations? Also limitations. Right now, a contract account pays for contract invocation. So as I already said, for example, you can make a smart account with a smart contract with one word, true, and everybody can make a transaction from that account. But that account, the smart account, will pay transaction fee, not the caller. Only that smart account can pay right now fees. And sometimes it's tricky to make atomic state change and transfer. For example, if you want to write some data and send some tokens, to make it atomic, to make it like a transaction, both or none of them. If you want to make that kind of behavior, some kind, it's tricky to be honest. And incoming transfer doesn't trigger contract. It's very important to understand only outgoing transactions. So, smart accounts cover basic cryptocurrency scenarios like multi-signature wallets, atomic swaps, token freezes, whitelist voting, and right now we will talk a little bit about these examples. Let's start from the beginning, from multi-signature use case. Um, what is a multi-signature? Multi-signature allows creating accounts that cannot be controlled by one person. In order to make a transaction, the required parties must provide their private keys simultaneously. So we have a transaction, we have an account controlled by, for example, 3 persons, and at least 2 of them should sign a transaction. Okay? Okay. So by default, you can imagine that account, not smart account, just usual account, has uh, a contract with this body on your screen. So Bob public key is like some base 58 string, and sig verify, it's a function which checks the signature of transaction. So it accepts 3 arguments. First is the body bytes of current outgoing transaction. Second argument is a signature, and the last argument is a public key. So it just checks the transaction signature against this body and public key. And you can imagine that default behavior of usual account, just like sig verify of every outgoing transaction with this proof, with this signature for this public key. What is a multi-signature and how it will work? For example, we have 2 accounts. We have 2 users, Alice and Bob, and we have their public keys, not private keys. And if we want to make a multi-signature 2 of 2, so both of them should sign every outgoing transaction from the account. If we want to make that kind of transaction, we write these 3, to be honest, 4, but 3 lines of code. We just define 2 public keys, and we write that sig verify for first proof, for first signature against Alice's public key. So check the signature for this transaction for Alice's public key, and there's a logic operator and check the signature for this transaction, but second signature, proofs with index 1, against Bob's public key. That's it. And this script, as you can see, there is no return keyword or some kind of that. Script is just like one function, you can say so. And the last line is a return statement. So the result of a smart contract is the last line. And very important thing to understand, always smart accounts contract should return true or false. If it returns false, transaction will not go to blockchain. If it returns true, transaction is allowed and it can go to the blockchain. That's it. So this is a simple example of multi-signature 2 of 2. Let's make it a little bit more complex. For example, we have 3 persons, Alice, Bob, and Cooper, and their public keys. And we want to make a multi-signature 2 of 3, not 2 of 2, 2 of 3. And we assign to, let's make it so I think I can explain it better like now. For example, we have Alice, Bob, and Cooper public keys, and we will check for each of them was this transaction signed by this public key by this person or not. And if it was signed by this person, just write to some variable 0. Otherwise 1. No. If this transaction was signed by this person, write to the variable 1, otherwise 0. Yeah, that's true. So we have 3 variables, Alice signed, Bob signed, and Cooper signed. And if the sum of these 3 variables more or equals to 2, this transaction is valid. So the last line, as already said, it's like a return statement. It's a result of the script. So if we have 2 signatures of 3, transaction is allowed. The important thing to note that for this transaction in proofs array, the signature from Alice should always be the first one, signature from Bob should always be the second one, and signature from Cooper should always be the third. So it's very important to understand that we can't, for example, in proofs array, put Bob's signature as first item. We can't do so in this example. Okay, Let's just compare with Ethereum multi-signature. We will not talk about it a lot, just like this is multi-signature smart contract in waves, like 7 lines of code and 2 lines of just like description. And this is 1 screen, 2 screens, 3 screens of code in Ethereum. So as I already said, the main idea behind Ride is to make it really, really simple. Really, really simple. Okay, use case number 2, betting. Where is betting? It's a very, very, very common scenario. 2 or more people can make a bet on any sports game with specified conditions. When the result is decided, the winner automatically gets his reward. Okay, let's imagine that we have that use case. The very first step we have to do, we have to fund the account. So we have to send to an account some money from 2 parties. We have defined the 2 parties. It's Alice and Bob with their public keys. Next, we have to define some game oracle. Oracle should save in blockchain the game result. So, for example, we can't get a game result from the blockchain because blockchains can't go outside. Only somebody can store it inside the blockchain. So we define that there is an oracle. We trust that oracle, and he stores some data in blockchain. In our case, he will store string value as a data transaction. The key for that value is World Cup 2018 champion. The value is a result of game the game. And now we have to define who is the winner. And we can do it using pattern matching. In this case, we just write that, okay, if string of game result is a string from data transaction. If winner is a string and it equals to France, then Alice is a winner and we store her public key in a winner variable. Else, if our oracle stored in blockchain string equals to Croatia, then the winner is Bob. Otherwise, just throw an exception that Oracle posted some unexpected result. That's it. Again, we just define 2 public keys. We define the public key for Oracle. We also get from data transaction the value of the game, and we check that if France, then the winner is Alice. Else, the winner is Bob. And in the end, we just call SigVerify function, and we check that only winner can take money from that account, can make a transaction from that account. So to be honest, blockchains can't pay to the winner, I don't know, automatically. The winner should make a transaction and should get his money. He should do it by himself. Okay, that's it. It's a simple example of betting. Another use case of non-fungible tokens. For example, what is a non-fungible token? Let's start from it. Non-fungible tokens are used to create a verifiable digital assets. These can be used in specific applications that require unique digital items. It's very, very common in games, crypto collectibles, and usually it's very important that each item should have its own ID, its unique ID. In this case, for example, we have an account and we can store in data transactions of this account some key value pairs. For example, we store that token number 1, it's a key, and the owner is Alice, and her public key we store as value of this key. And okay, we just store in data transactions pairs with the ID of token and owner's public key. Okay, let's make it better. Smart accounts allow to change the behavior of that storage, let's call it so, of non-fungible tokens. And for example, we can write a smart contract which verifies that only the owner of this token can change, can transfer this token to somebody. By transfer, I mean that in data transaction we will change the value by that key. So, for example, Alice, and she owns this token number one. To change the owner of the token number one, Alice should send a transaction. So data transaction. Data transaction should contain that token number three. Oh, okay, let's take token number three. Token number three. We change the value for this key to Cooper's public key. It was Alice's public key. Now it should be Cooper's public key, and Alice should sign this transaction. And smart contract can check that, okay, this is a token number 3 key and the value is Alice's public key. The transaction, this data transaction was signed by this public keys account. Okay, this transaction is allowed, and we can update our data transaction, our data attached to an account. And after this transaction, the value of token 3 key will be Cooper's public key. I think it's clear enough. To do so, we just check that this outgoing transaction, tx is a global variable, it's available in your contract. We check that this outgoing transaction is a data transaction. We get old owner's public key. We extract from key. We just check that new owner. We just check that in this outgoing transaction there is a binary data, and we check that this transaction tries to update only one key, only one value for one key, and we check the signature for this transaction. So we check that old owner signed the transaction, the transfer of non-fungible token. That's it. So if any user, for example, if Cooper will try to make a transaction and he sign a transaction, for example, with token 3, in this case, token 3, the owner of token 3 is Alice, and if Cooper will try to make a transaction with his signature, it is not allowed. Again, if Alice will try to transfer token number 5 to Cooper, it's not allowed also because there is no token number 5. Okay, so again, smart contract can just check some variables, can just check some conditions, and if everything is okay, transaction is allowed. Okay, again, why we like this model? Because it's really close to code is law definition. It's like a dream of all blockchain developers and blockchain users, that code is law. Also, it's straightforward for payment channels and for state channels. I hope in the near future we will see the Lightning Network in Waves blockchain. And let's go to smart assets. They just were released in early January, as I already said, and it's almost same as an account. You just write a contract which checks some values, and the only difference is that smart accounts contract should be called every time when this account tries to make a transaction. In case of smart assets, the smart contract of smart asset, the contract of smart asset, should be called every time when somebody tries to make a transaction with this asset, with this token. So it allows to make token freezing, notary control transfers, trading on DEX. You just can, for example, whitelist. So you can make whitelist trading. So you can issue a token and say that, okay, this token can go only to this list of accounts, to this list of addresses. and you can make countable inflation. You can change the behavior of your token. That's the main idea. So to issue a token, you just have to send one transaction, issue transaction. It's really simple. Just like in our Waves client, you have to fill 4 fields and press the button, and you have your own token. But if you want to make it smart, if you want to change the default behavior of that token, you can write a smart contract and deploy it, and your asset will become smart. Okay, to make your asset smart, you have to send special type of transaction set asset script. Um, as you can see, there is a set script transaction if you want to make your account smart, and there is a set asset script transaction which allows to make your asset smart. Okay, let's talk a little bit about tools. Usually users and developers ask me how to start developing smart contracts. The very first thing you need is a Waves Explorer, wavesexplorer.com. You can see there all transactions blocks. You can see transactions and blocks in mainnet, in testnet. You can configure it to work with custom network, custom blockchain. You can run your own blockchain, and you can work in your blockchain, for example. The second important thing is a Waves Keeper. It's a browser extension which allows to store private keys. It allows to integrate you can integrate it into your web page, and for example, every time when user should make a transaction, you should not ask his private key. You just write some JavaScript, and this Waves Keeper window pops up, and user just clicks OK. So it is not secure to ask some user's private key, so you can use Waves Keeper and integrate your applications with Waves Keeper. Waves documentation at docs.wavesplatform.com. You can go there and find a lot of details about smart contracts, about Waves blockchain, Waves cryptography, cryptographic details, everything about Waves. And there is also a REST API for Waves node. Also, there are public nodes at nodes.wavesplatform.com. You can use them, for example, to get some data from blockchain, to see transactions, to check that transaction is in blockchain, to even to broadcast transactions, so you can sign it locally using your some code using libraries, and you just can broadcast using public blockchain nodes. There is also an IDE with the console, with REPL as we call it. You can write there a smart contract. It allows also to compile it, to work with different accounts, to send any type of transactions using the console. So if you are interested in writing smart contracts, I think it's the best place to start. Also, there is a DevToolkit, which allows to run your private blockchain with one simple command. Why it's necessary to run your own blockchain. For example, in our testnet and mainnet, the average time for one block is 1 minute. But sometimes, especially when you develop something new and you want to test it fast, you want to decrease the time span between blocks. So if you want, for example, to change the behavior of blockchain to get blocks every 15 seconds, you can run your own blockchain and test your smart contracts against that blockchain in that blockchain. So you can do it using DevToolkit. It also allows to run your own explorer, your own client, and your own data service. And it's very, 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 very simple to run your own blockchain, and you control it. You just have everything. Just stop it at any time, run it at any time. So you can go to the GitHub page, and you can find more details there. So github.com with platform dev toolkit. Also, there are API libraries. Not only API, to be honest, all of them can also sign transactions. You can use libraries for JavaScript, Java and Scala, for C#, for Python, for Go, for Rust, for PHP, but mostly I think the best libraries are for JavaScript, Java, Scala, C#, and Python. You can find for PHP, as I already said, Go, Rust, but you can find it in our documentation. Again, all tools on one slide. Documentation at docs.websplatform.com, Explorer, websexplorer.com, Smart Contracts ID at id.websplatform.com, JavaScript REPL, where you can run some JavaScript code with our JavaScript libraries. It's like demo.websplatform.com example console. Data service. It's a service like you can get some statistics, some information about transactions from relational database from PostgreSQL. Um, with and you can also use public nodes for data service at api.websplatform.com. Also, I got a lot of questions about how we plan to improve RIDE, what we will add in the future. In future, we will definitely improve RIDE and we will make it more suitable for dApps. For example, in future you'll be able to define functions. You will be able to call that functions, make it callable. So there's one limitation right now that call you cannot make a transaction from another account and pay fee. Only that account can pay fee, that smart account. In case of RIDE for dApps, you can make a smart account, you can define their callable function, and every user can call that function and pay fee. Not your account will pay fee, not your smart account. Also, it will keep fixed cost without gas. So we also have blog post about RIDE for dApps, so I also add the link to the description of this video. And I think in near future we'll also have non-fungible tokens, not with data transactions. I think we'll have them in the core. We actively work on it, so in near future we'll have NFTs. And also Turing complete smart contracts, but I hope in future we will make a separate video about Turing complete smart contracts for Waves. That's it. Thank you very much. If you like this video, like, subscribe, share. I hope in future I will make more videos about Waves, about blockchains, about technologies. So if you have any questions, feel free to ask and feel free to write, to leave your comments on this video. So thank you for your time.